A distant glow hangs like a soft promise above the horizon. It is not a single star, but the combined light of countless suns gathered into a single, gentle presence. Close your eyes if you wish, or let your gaze soften. Breathe slowly and deliberately. This narration will follow the pace of your breath, unhurried, steady, patient. Imagine a spiral of light so vast that its arms sweep across hundreds of thousands of light years. That spiral is Andromeda, a neighboring galaxy whose glow reaches us after a journey measured in millions of years. Picture the scale without strain. A distant city of stars, each window a sun, each street a river of dust and gas. Some of those suns burn hot and brief, brilliant blue beacons that live fast and end in spectacular explosions. Others are small and steady, red embers that will glow for times far longer than our species has existed. Together they form a tapestry of light that has traveled for more than 2 million years to reach us. Every glimmer we catch carries the story of a distant sun, a cloud of dust, or a world no one will ever reach. Let that sentence rest in your mind like a pebble dropped into a still pool. Watch the ripples slow and fade. When you look toward that faint oval in the night, you are looking back in time. The photons that touch your eyes began their journey long before the first human stories were told. They crossed the cold, silent gulf between galaxies, carrying the memory of births and deaths, of clouds collapsing and stars igniting. Andromeda is not merely a neighbor, it is a mirror. From our vantage, we study it as an external galaxy, a chance to see what our own Milky Way might look like from afar. Its spiral arms, its dusty lanes, its bright core, each feature offers a lesson in how galaxies live and change. The arms of Andromeda sweep outward for hundreds of thousands of light years. They are not fixed ribbons, but waves of density that move through the galactic disk. As these waves pass, they compress gas and trigger the quiet miracle of star formation. In those compressed clouds, gravity gathers matter until a new star ignites and a new light is born. Within the galaxy's heart, an older population of stars glows with a warm, golden hue. These are the elders of the system, small, steady suns that have burned for billions of years. Their light is a soft, constant hum against the deeper dark. Astronomers have found evidence that a massive, unseen object sits at Andromeda's center. The motions of stars there suggest the presence of a supermassive black hole, a silent engine whose gravity shapes the orbits of nearby stars. In some observations, 2 bright points appear where one might be expected, hinting at the possibility of 2 black holes slowly circling one another, a relic of ancient mergers. Surrounding the visible disk is a vast, diffuse halo, an invisible envelope of gas, dust, and the mysterious substance we call dark matter. This halo extends far beyond the bright spiral, shaping the galaxy's gravity and holding its outer stars in place. Dark matter cannot be seen, yet its presence is clear in the motions of stars. The outer stars orbit almost as quickly as those nearer the center, a sign that an unseen mass provides the extra pull. Think of dark matter as a scaffold, an invisible framework that gives the galaxy its shape. Andromeda's life is written across many wavelengths. In radio light, we trace cold gas. In infrared, we see warm dust. In ultraviolet, we find the youngest, hottest stars. In X-rays, we glimpse the most energetic events. Each band reveals a different face of the same grand system. Within the arms, clouds of hydrogen glow faintly when energized by nearby stars. These nebulae are stellar nurseries, places where gravity gathers gas into denser knots until fusion begins and a new star is born. Picture a cloud collapsing, shrinking, heating, until at last a pinprick of light appears and grows. Not all endings are gentle. Some stars die in violent explosions called supernovae, releasing more energy in an instant than our sun will emit in its entire life. Those explosions scatter heavy elements, iron, gold, oxygen, into the surrounding space, seeding future generations of stars and planets. Imagine the slow, patient work of chemistry across generations of stars. Each cycle of birth and death enriches the interstellar medium, building the raw materials for rocky worlds and complex molecules. Over time, the galaxy's chemistry shifts, and new stars are born with richer element mixes than their ancestors. Andromeda is accompanied by dozens of smaller satellite galaxies, each orbiting and slowly influenced by the larger system's gravity. Over time, some of these companions are drawn in and absorbed, their stars strewn into long tidal streams that arc across the halo. Those streams are like fossilized rivers of stars, remnants of galaxies that once were. By tracing their paths, astronomers reconstruct Andromeda's past, an archive of mergers and quiet consumption that built the galaxy we see today. The disk itself bears scars of past encounters. It is warped, bent like a ripple frozen in time, evidence of gravitational tugs from long ago interactions. Even a galaxy that appears serene carries within it the memory of collisions and close passages. Andromeda is moving toward us. Its light shows a slight blue shift, a subtle sign that the galaxy is approaching at a speed measured in hundreds of kilometers per second. Over billions of years, this approach will culminate in a slow, majestic merger with our Milky Way, a dance that will reshape both systems. Imagine two vast oceans slowly meeting, their currents intertwining. Stars will mostly avoid direct collisions, but their orbits will be altered, stretched into long tidal tails, and eventually settled into a new, larger structure. The result will likely be an elliptical galaxy, a calm, rounded system glowing with the combined light of both progenitors. For now, the approach is a distant promise. The first close encounter is expected in roughly 4 billion years, a timescale that allows us to reflect rather than fear. Let that distant certainty be a quiet thought as you breathe in and out. Within Andromeda, bubbles of hot gas rise above the disk, vast structures visible in X-ray light. They are the galaxy's exhalations, formed by waves of supernovae and intense stellar winds that push material outward into the halo. These bubbles carry heat and heavy elements, enriching the surrounding medium and shaping future star formation. The chemistry of stars tells a story of enrichment. Older stars are poorer in heavy elements. Younger stars are richer. Each generation builds upon the last, accumulating the products of previous stellar deaths. This slow alchemy is how planets gain the raw materials for rocky surfaces and, perhaps, for life. Consider the possibility, quiet and speculative, that some of Andromeda's stars host planets. If even a small fraction does, the number of worlds within that galaxy would be beyond imagination. Each planet would carry its own climate, its own history, its own chance for something like life to arise. Yet the vast distances between galaxies make direct contact unlikely. A signal sent from one galaxy to another would take millions of years to arrive. Communication across such spans is a thought experiment more than a practical plan, a reminder of the scale that surrounds us. As you listen, let your breath match the slow rhythms of the galaxy. Inhale gently, exhale slowly. Each breath is a small orbit, a tiny cycle within the grander cycles of stars and gas. Andromeda's outer halo may already touch our own. The tenuous envelopes of gas and dark matter that surround both galaxies extend far beyond their visible disks. And in those outer reaches, the two systems begin to overlap. It is a subtle contact, a whisper before the larger conversation of merger begins. The galaxy's rotation, the motion of its stars, the faint streams and clusters, all of these are clues. Astronomers map them patiently, like readers tracing the lines of an ancient manuscript. Each observation adds a new sentence to the story of how Andromeda grew and changed. Now, allow your thoughts to soften. Let the image of that distant spiral hang gently in your mind. Imagine the slow sweep of its arms, the warm glow of its core, the faint halo that fades into the dark. If your eyes are closed, feel the weight of your body sink into the surface beneath you. If your eyes are open, let them rest on a single point and soften the focus. Breathe in, and as you breathe out, release a small tension. Andromeda's light continues its long journey. Its light takes more than 2 million years to reach us. For now, it reaches you as a quiet companion in the night, a reminder of the vastness and the patience of the cosmos. Let that patience settle into you. Let the slow, steady cadence of the galaxy become the rhythm of your breath. Good night.